I'm going to show you how to use the R companion package's regC function to do bivariate regression analysis. I'm assuming you've already downloaded R in RStudio and have installed the RC3AP package. If you haven't done that already, you want to complete your setup before trying to use functions from the package. I'm also assuming that you have a basic understanding of how to work in the R environment. If you don't know what functions and objects are, you should review those concepts before practicing the skill demonstrated in this video. The regC function is one of the most powerful functions in the RCP3A package, and we use it a lot in the book. In this video, I'm going to focus on the regC function's required argument and how you use it for bivariate regression analysis. I will cover other uses of regC like multiple regression analysis and residual diagnostics, which come up later in the book in separate videos. The regC function has one required argument, formula, which is set equal to the regression equation to be estimated. As you'll see, we use a special syntax for formulas that you need to learn to use regC. The regC function supports a standard set of optional arguments. With regC, you have options to specify observation weights, the dataset name, the number of digits you want to see after decimal points, and whether you want to print your results to an HTML file in your working directory. I will briefly discuss the ANOVA argument in this video as a measure of model fit. I will discuss regC's other optional arguments and plot-related arguments in other videos about the regC function. To learn how to use the regC function, let's work through some examples together. To do bivariate regression analysis with our regC function, we will type it in by name. There's one required argument to this function. It's formula. I don't need to type it, this is the first one, but to make it example maybe a little bit more clear, I will put it in there. So we set formula equal to a formula. I'm going to show you the help notes to clarify this. So the formula should be in the special form of dataset $ dependent variable tilde dataset $ independent variable. And with bivariate regression, that means we have one independent variable. So let's see what that looks like. So we could say I'm going to pick something from the world data set this time. We will look at the this piece index variable, and we will run a regression analysis with piece index as the dependent variable, and I will pick spending on the military as the independent variable. So it's the formula set equal to the dependent variable and then the tilde, then the independent variable. And this tilde, to this point in the videos, we haven't encountered, I don't think we've used the tilde yet. That's the key that's on the top left of your keyboard, or most keyboards. So it would be shift and then that top left key. It's the key to the left of the one on your keyboard. So let me run this and we'll look at the results together. So when you run the regC command, you get several results, like a table of the coefficients with the estimates and the inferential statistics, a table summarizing the regression residuals, and then some additional information on the model fit and N in the model. What I think is nice about our regC function is we've packaged together several things that are separate, otherwise separate. So if you see regression analysis in a lot of textbooks and guides, it'll have one function to sort of estimate the regression model, another one to summarize it, maybe another one to report on the regression residuals, and then some ancillary functions to get additional model information. And what's nice about the regC function is it basically packs all of that into one. So with one function call, the regC function call, you can do the work of 4 or 5, what's usually 4 or 5 different function calls. And I also want to show you that you can do a weighted regression analysis, weighted bivariate regression analysis as well. I don't want to do that with the world data set. I want to do another example of a weighted bivariate regression. We use the regC function again, and as I mentioned, it has one required argument, the formula, and then to weight the observations, use the W argument, which is similar to our other functions, and we set the W argument equal to the dataset variable that weights observations. So for this, I'm going to use the example from the NES dataset, and I will do another feeling thermometer. Let's say feeling thermometer toward big business as a function of, let's say age. It's a nice interval level variable, and I want to weight observations using the variable in the data set WT. That's in this particular data set, the variable that weights observations. So for a weighted bivariate regression, you set the formula equal to the dependent variable as a function of some independent variable, and then separately use the W argument to specify the variable weights, or the observation weights. Let's run this and take a look. So very similar output here with weights specified. We're a weighted bivariate regression analysis. We get a table of our regression coefficients, again with the estimate and the inferential statistics. We have a table reporting the information on the regression residuals, and then some additional information about the model fit, and similar good stuff. Of the regC function's ANOVA argument. When you run regression analysis with the regC function, it has the standard output for coefficients, a table regarding regression residuals, additional information about the model, and within the additional information of the model includes probably the most popular, most common measures of model fit, the R-squared value, which in this case is 0.086, and the adjusted R-squared value, in this case 0.07995. In the next line, those are the most common measures, and the next line reports an F statistic, which is a measure of the overall fit of the model, which would be very similar to what we already have reported, because we have a bivariate regression with one independent variable. But this will pop up in all the regressions that we run with regC, so I want to briefly comment on that. That'd be more useful in the multiple regression context than it is in the bivariate regression context. So it reports kind of the top level results here. F statistic of 13.86 on 1 and 147 degrees of freedom, with a p-value of 0.0002797. If we want to unpack that a bit, we can use the function's ANOVA argument to obtain a table, and this will supply as a table to provide some additional information about the calculation of that F statistic, which can be a measure of a regression model fit. So the ANOVA table unpacks the calculation a bit. I mean, we have the same F statistic and p-value that we saw in the additional information, but it reports also the sum of squares explained by the independent variable and the residual sum of squares. If these terms are familiar to you, we'll cover them in more detail in the chapter on analyzing regression residuals. But since the additional information and model fit is an issue from the very first regressions of bivariate regression, I wanted to briefly discuss that ANOVA table and the additional information available from it.